In this video, we are going to talk about Module 1, Topic 1, Lesson 5, and it's going to cover absolute value equations and inequalities. So make sure you write your name and class period and the date on this paper. By the end of this lesson, you should be able to answer these essential questions. What are the steps to solving an absolute value equation? And what are the steps to solving an absolute value inequality? So here we go. You can solve many absolute value equations using inspection. So in the first example, we want to graph the solution set of each equation on the number line given. So we have the absolute value of x is equal to 5. We need to think about what numbers can we plug in for x so that the output gives us a 5. And so that would be x equals 5 and x equals negative 5. And so when we graph these, we are just going to plot a point at negative 5, and we are going to plot a point at positive 5. And that would be it. Looking at the second one, the absolute value of x is equal to a negative 3. So hopefully we recall that this is not possible because the absolute value always gives us an output of a positive number. So this would be no solution, which means we would not need to graph anything on the number line. Okay, so now we're moving into solving linear absolute value equations, and we need to be able to show our work. So if we look at this equation right here, the first thing you need to check for is that there is nothing being added, subtracted, multiplied, or divided on the outside of these absolute value bars. And in this case, there's nothing being added, subtracted, multiplied, or divided. So what we do here is, in order to drop the absolute value bars, we're going to come up with two different equations. The inside piece will always stay the same no matter what. It's what we set it equal to that accounts for a positive and a negative version of an input value. So what we do is we're going to take what it's equal to, which in this case is 3, and we're going to set it equal to a negative 3 and a positive 3, and now we just solve the two equations. So to solve, we're going to subtract 7 from both sides, and so that gives us x is equal to a negative 10. Then on the second equation, we are going to subtract 7 from both sides. And when we subtract 7 here, we get a negative 4. So these are the two values that would give us 3 when plugged into this equation. Okay, going on to the second one, if you want to pause the video and try it yourself, you can. But again, the first thing you ask yourself is is there anything that is being added, subtracted, multiplied, or divided to this absolute value? And the answer is no. If that's the case, you can take the inside piece as it is, and you can create two equations from it. First equation gets set equal to negative 12. The second equation gets set equal to positive 12. And then you just solve the equation. So to solve this, we will need to add 9 to both sides. And that would give us x equals negative 12 plus 9 is a negative 3. On the second equation, we will add 9 to both sides. When we add 9 to both sides, we get x equals 12 plus 9, which is 21. And so these are the two numbers that if we plugged it into this equation, we would get an output of 12. Okay, looking at the next one. So again, you ask yourself, is there anything that is being added, subtracted, multiplied, or divided to this absolute value? The answer is no. Now, what we do also need to pay attention to is that we don't go on autopilot mode. So what I mean by that is we got to check, what is this equal to? Well, in this case, this is equal to a negative 8. The absolute value cannot produce a negative number. So in this particular situation, because of that negative 8, this would be a no solution. Okay, but you have to be careful with that because sometimes you can get a solution from something like this. So an example of what would give us something with a solution even though it's set equal to a negative 8 would be something that maybe looks like this. and we have an additional something over here like this. Okay, in this case, you would need to multiply by -2 first. That way those can cancel out. And then you get 3x plus 7. And a -8 times a -2 is a positive 16. Now that 2 has been moved over, okay, now this equation is solvable. And you can drop the absolute value bars and set one side equal to -16 and the other equation equal to positive 16. So just because it's set equal to a negative, that does not always mean that it's no solution. You just have to make sure that it's only when the absolute value bars are equal to a negative. And there's no adding, subtracting, multiplying, or dividing that could change that outside number. Okay, so I'm going to erase that. Okay. Looking at the next one, the absolute value of 2x plus 3 is equal to 0. So when we go to drop the absolute value bars, typically we would say it equals 0, or a positive number and a negative number. Now, if you write -0, that looks goofy because 0 is not a negative number. It is just a neutral number. So this is the one and only type of example where you will only have one solution, and then you solve it just the same as everything else. So we're going to subtract 3 from both sides. That gives us a 2x equals a -3. Then we would divide both sides by 2. So then x is equal to a -3/2. Okay, and again, you can always plug this in to check your answer. Now, looking at letter E, we ask yourself, is there anything being added, subtracted, multiplied, or divided to the absolute value? And in this case, yes. This 16 is being added. We need to move this over before we do anything else. So to move it, we are going to subtract 16 from both sides. And that gives us the absolute value of x is equal to 16. Now we can go ahead and drop our absolute value bars, but you have to remember when you drop them, one is set equal to -16, one is set equal to positive 16. In this case, the x's are by themselves, so we're done solving that one. Okay, moving on to the next one. This one, again, you ask yourself, what is the absolute value bars? Is there anything being added, subtracted, multiplied, or divided? In this case, yes, a 6. But the other thing that may throw some people off is that now your x is on the right side. If you have an issue with this, what you can do is you can just move this 23 to the other side, and you can solve it like we've been solving everything else. But if it doesn't bother you, then you can solve it, and I promise you'll get the same answer. So we have to move the 6 first by subtracting. And so we get the absolute value of x minus 8 equal to 23 minus 6, which is 17. Okay, so now the absolute value bars are by themselves. So you can take the equation and write it 2 times. One will be set equal to -17. One will be set equal to positive 17. And now you solve each equation. So to solve, we are going to add 8 to both sides. And that gives us x is equal to -17 plus 8, which is a -9. On the second equation, you can add 8 to both sides. And we get x is equal to 17 plus 8, which is 25. And so we got 2 answers here. Okay, moving on to the next one. Again, you ask yourself, is there anything being added, subtracted, multiplied, or divided to the absolute value bars? And the answer is yes. We have something that is being multiplied. Okay, in order to multiply, or in order to move that 3, you will have to divide both sides by 3. Okay, what you are not allowed to do is you are not allowed to distribute that 3 to the inside of the absolute value bars. Because they are absolute value bars, they are protected from being multiplied. So when we divide both sides by 3, we get the absolute value of x minus 2, and that gives us 4. From here, we can drop the absolute value bars because now it's all by itself, and we get our two equations. Remember, for our two equations, one is set equal to -4, one is set equal to +4. To solve, we are going to add 2 to both sides, and that would give us x equals -2. And then over here, we would plus 2 to both sides, and that would give us x is equal to 6. And so those would be our two solutions. Okay, looking at the last one for this first video. Okay, same concept as the one above it, but this time I'm not going to move the 35 to the other side, but if you don't like it, you can move it over here and solve it, but I'm going to keep it this way this time. So again, we asked ourselves, is there anything being added, subtracted, multiplied, or divided to the absolute value bar? And in this case, we actually have something being subtracted and multiplied. When you have two things happening, you have to add or subtract first, and then worry about the multiplication or the division. So, on this problem, you have to first start by adding 10 to both sides. And that would give us 45 is equal to 5 times x plus 6. Then you can worry about the division and divide both sides by 5. And so that would give us 9 is equal to the absolute value of x plus 6. And so from here, you can write your two equations. So we're going to have x plus 6 and x plus 6. You're going to have one -9 and one +9. And then you solve the equation. So we would need to subtract 6 from both sides. When we do that, -9 plus 6 is a -15, and that's what x is equal to. And then on the second one, oops, I made a mistake. Let me fix that to a plus sign. On the second one, you also need to subtract 6. But when you subtract 6, you're going to get 9 minus 6, which is 3. Okay. So that is it for the first part. So you should be able to answer the first essential questions. What are the steps to solving an absolute value equation? And you should be able to write those. So there will be a part 2 for the second half of the lesson.